Hey boys and girls, today we are going to start getting almost into geometry. Today we're going to be looking at adjacent and vertical angles. I thought it was up there, it's not. But you should have a worksheet in your hand and it looks similar to this. I'm going to go through a couple of these things with you just so you get the best understanding of what I would like for you to be doing today. So if you look at the essential question, it says, what can you conclude about the angles formed by two intersecting lines? So when we have two lines that cross each other or they have a vertex, this dot where two lines come together, that's what we call a vertex. So what can we conclude? What can we tell about? What can we infer about the angles formed by two intersecting lines? So when two lines come together, what do we know about them? I think that these are things that you've learned before. So an acute angle is an angle that's less than 90 degrees. 90 degrees is a right angle. We can tell that something is a right angle by this little red triangle in the bottom. It's not a triangle, it's a square. So by this little red square in the bottom, we know that it's a right angle, which is 90 degrees. Obtuse angles are bigger than 90 degrees. So I like to think obtuse, really big. That's how I remember that. And then a straight line is 180 degrees. So this is 90 degrees and a straight line is 180 degrees. If you look at activity 1, I would like for you to do activity 1, 2, and 3 today. So if you look at activity 1, it's asking you to draw the hands of the clock to represent the given type of angle. So if I were to draw an acute angle, I might say 1 o'clock is an acute angle. You can't use that one, you have to use a different one. But then you can go through and do those for all of those. Part B says, what is the measure of the angle formed by the hands of the clock at the time given? So at 9 o'clock, if I use this one over here, at 9 o'clock, what kind of angle would that be? Would it be acute? Would it be right? Would it be obtuse? Or would it be a straight? So you can write those down here. So you can go ahead and hit pause on this video and take a minute to do activity 1. On activity 2, before you start on activity 2, I want to talk about the word adjacent. So adjacent means right next to each other or they share a border. Their example is Maine and New Hampshire. They share this border right here, so they are adjacent to each other. Michigan would be adjacent to Ohio or Indiana because we share a border with them. My classroom here would be adjacent to Mrs. Johnston's or Mrs. Ryan's because we share this border, that wall. So if you flip this over, we get to activity 2. Activity 2 is a little bit more difficult. So for this one, you'll have to pay closer attention. This says work with a partner. You're actually working alone because some of you are finishing up a test. So you're probably working alone unless a guest teacher gave you permission to not work alone. Some angles, such as angle A, can be named by a single letter. So this here is angle A. That's a right angle, angle A. I've got angle F, angle C, and angle D. We use that little angle symbol. Can be named by a single letter. When this does not clearly identify the angle, you should use 3 letters as shown. So I've got point on one side, so I've got one side, the vertex. Remember, the vertex is where two lines come together, and E is the point on the other side. So if I was looking at angle BDE, I would have to find B. So angle B, go down to D and over to E. So angle BDE is an acute angle where D is the vertex. It says name all of the right angles, acute angles, and obtuse angles. So what you'll need to do is you'll need to make a space on your paper and write acute. I'm hoping that you can see this. And you can, but barely. So I'm gonna move you over. There we go. So we've got some acute angles. This angle BDE would be an acute angle. Another acute angle would be, let's say, DBC. This angle right here, that's less than 90. So angle DBC. You should be able to find 1, 2, at least 2 more on your own. It wants you to find right angles. You should be able to find at least 4 right angles. One example of a right angle would be angle FAB. So I'll write angle FAB. And then I believe that there is one obtuse angle. It's really tough to see. I will give you a hint. I'm not going to tell you what the name of it is, but it is right through here. This is that obtuse angle. So I want you to see if you can name it yourself. And then I want you to see if you can think about which angles are adjacent. So which angles share a border? So for that, you're gonna need 2 different angles. Let me erase this so you can see. So adjacent angles, they share a border. So one example of an adjacent angle would be angle EBD, angle EBD, and angle CBD. And that's because they share this line right here. It's a line that they share, it's a border. I would not say that angles FEB, so this right angle, and BED, oh actually, those are adjacent angles, look. They share that line right there. So that's another example of adjacent angles. Angle FEB and angle BED. So these are adjacent angles because they share this border right here. You can oftentimes tell that 2 angles are adjacent when they have a common middle letter. So for instance, these have the vertex B in common, so they are adjacent angles. And here I've got the letter E as my vertex, so they are also adjacent angles. If you go down here to activity number 3, you can see that you are going to need to use a protractor for this one. So you will get a protractor. If you don't already have one, you can come up to the front and get one. It says, how many angles are formed by the intersecting roads? So an intersection, you might have heard of that at a lot of intersections of real roads. There are either stop signs or stop lights. It's where 2 roads cross. So if we look at how many angles are formed by the intersecting roads and number the angles, so I've got an angle here, 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 and here. So how many angles are formed? And then I want you to take a minute and take your protractor, and I want you to try to measure each angle. So I have a large protractor, you have a little small one. What you're gonna do is at the very bottom here of your protractor, you'll see a small lowercase t. You're gonna put that lowercase t right where your 2 lines come together. And then if you see here, this comes out, oops. If I put my T right in the middle there, this comes out to here. So I have to make a decision. So I see about 65 and 115. That's what it looks like to me. About 65 or 115. So does this angle look like it would be 65? Is it less than 90 degrees? Or does it look like 115? Is it obtuse? It's for you to decide. And then you can talk about maybe what this angle is, what this angle is, and what this angle is to answer these two questions. Once you have finished activity 1, 2, and 3 on that colorful piece of paper, what I want you to do is I want you to get a scrap piece of paper and I want you to try to draw some of your own angles. Let's start with drawing a 40-degree angle. You can do this as I do this on the board. So how we do this is we are going to start by using the straight side of our protractor. So I've got the straight side of my protractor and I'm just going to draw a straight line. And somewhere on that line, I'm gonna go ahead and put a dot where I think that the center of that line is. So I've got a dot at the center of my line, and now you see that little T at the very bottom of your protractor. You're going to line up where that T intersects, where those two lines come together. You're gonna put that intersection right on your dot. So this would be my T. And now I was asked to draw a 40-degree angle, so I'm gonna find 40 on my protractor. I see 40 about here, so I'm gonna draw a little tick mark there. And so I have my straight line and my small tick mark. I'm gonna use the straight edge to go all the way through and create intersecting lines. We oftentimes will put arrows on these lines because we don't know where they start and where they stop. So I will do that. So now I need to decide, because I've created 4 angles, essentially 1, 2, 3, and 4. So this first angle, is this one 40 or was this one 40? Well, I know that this one is 40 because this is an acute angle. It looks like it's less than 90 degrees. So this one has to be 40 degrees there. If this angle is 40 degrees, that means that angle 3 is also 40 degrees. We call those vertical angles. We'll get into that later. But these two angles are opposite of each other and they're also the same. So if I wanted to figure out what angle 2 was, well, I know that angle 1 and angle 2, together they form a straight line, and straight lines are 180 degrees. So there are a few ways I can figure this out. The first way I can figure it out is if you look at your protractor where it says 40 degrees, there is a number on top of that angle. That is the opposite angle, so, or next to the angle adjacent or next to. So if this one's 40, then the one next to it is 140. I know that that's true because 140 plus 40 equals 180, which is a straight line. I also know that if angle 2 is 140 degrees, angle 4 is 140 degrees because these angles are opposite. They're vertical angles, they're the same. Let's see if we can draw an angle that's 85 degrees. So I'm gonna start this the same way with a straight line. And I want you to go ahead and put your dots somewhere in the middle, somewhere where you think is the middle of your straight line. Then you're going to put where your line intersects. So your little T there is going right on your dot. And you are going to find 85. So in between 70 and 80 would be 85. So that's about here. So now I will draw my line all the way through my dot and the line that I just created. I'm also going to extend these arrows since I'm not sure where the lines start and where the lines end. Now I need to decide which one of these is 85 degrees. Is it this one or this one? Well, I know that it's this one because this one's less than 90 degrees. So it's an acute angle. And if this angle here is 85, this angle here is also 85. Now, I could either look at my protractor and say, okay, so in between 70 and 80 is 85. So what's in between 110 and 100? Well, that's 105. And then this one would be 105 as well, because these two lines, they make a straight line, so that means that they are 180 degrees. If I didn't have my protractor handy in front of me, what I could also do is 180 degrees minus 85, because this part here is 85. So 0 minus 5 I can't do, but 10 minus 5 is 5, and 17 minus 8 is 10. So that leaves me with 105. What I'd like for you to do next is I would like for you to try these problems on your own. So if you need to grab a new scrap piece of paper, you can, but put your name on your scrap paper. And I want you to try to do these problems on your own. So use a protractor to find the measure of the angle, then classify the angles as acute, obtuse, right, or straight. So you don't have these in front of you, so why don't you just look at these ones and tell me obtuse, acute, right, or straight, obtuse, acute, right, or straight, obtuse, acute, right, or straight, and then go ahead and use your protractor to see if you can get these angles. See if you can measure out these angles with your protractors. Turn this in at the end of the hour, whether you're finished or not. I just want to see how far we got today, okay? Hope you're having a good one.